the residents, 1 to 3 families, and how that seems to have a void in there, and who can touch it, who can't touch it. So you're really going to have to find out, because this document that I created for construction control really applies over 35,000 square feet. Can you use it residentially? Of course you can. You can say, I'd like you to use as one of your repairs and procedures and guidelines, say, hey, our procedures and guidelines is that if you're touching a fire escape, we'd like you to use this document primarily used for commercial control. But because it's a fire escape and it's a life safety issue, we want to identify who the engineer of record is going to be on this, who's going to babysit this thing. So whatever you have to do, so I'm not going to say yes you can, I'm going to say I think you could basically ask the specific case to say, Mr. Engineer of this residence, I'd like you to use these 2 documents, which we primarily use on commercial application, and this will assure me that this thing is under control.
Yeah, I need a legal path.
I wish I knew it, but if anybody here knows the legal path, just spit it forward.
I understand what you're talking about in the program and stuff, but if I get resistance, I gotta go.
Yeah, I would just, speak with Gene, I would speak with the state, I would ask the state, what is the thing? You're just basically trying to close up a loophole, and believe me, the residential side of things, it's a huge, huge hole. But, you want engineer oversight anyway, so engineer oversight with or without that document is something you want anyway on all fire escape activity?
It depends, yeah. So
you're going to let the vendors? You said depends. You're going to let a vendor pull a permit without any guidance?
Right now for the 5-year inspection, it doesn't care. One is the mass code, one's the international building code. So under mass code, the fire escape outfit, they need to every 5 years.
Right, every 5.
So that would allow either an engineer, architect, or someone who's qualified.
Right. So that's engineer oversight.
Correct.
So he can either do that on the residence without this document, or you can say, what we'd like to see, we'd like to see this document
I'd like
used.
to be in my file so we have it for a record.
You're going to have to ask the state. I'm one man with
I
a...
understand, I'm just wanting for a legal pathway.
You may want to ask Bob because he checked that out, and again, I think it's going to be a mandatory for commercial activity, but I think it's going to be one of those suggested for residential activity. But you need engineer oversight anyway on residential activity, so it's one, do you let the engineer just kind of wing it with you on the residential side of things, or do you say, hey, you know what, just to make it simple, if you could follow the same format as this, I just need you to identify who the vendor is, who the engineer oversight is, how many visits you're going to come, where's your report so I can have a powwow with you on what your course of action is. It spot repair and full and a load test, because I want to see that criteria, or is it going to be one of those that you just come down and say, hey, we're refurbishing it all, every boat's being changed, and you're going to actually be the last guy in, because he goes through 3 visits to verify that all bolts got changed. You're the final one because the vendor's trying to get his permit signed off, and you're going to go there and try to find no old bolts. So let's take a look at some of this. You guys can see this thing was buried in the ground this deep. Look, if you look from the side, look over there, you're going to see all the welds that happened when somebody basically, to fix a fire escape, instead of fixing this broken bottom, what do? They put an angle clip underneath it. Another thing that they do a lot, so the rust is huge in here, right? But then they just weld the nose. And that weld, a lot of people who understand welding, as rust grows, it rips a weld. Welds cannot hold anything. If it's got any force, it'll basically just rip. So as it's ripping microscopically, one day it just gives. So welds snap, but bolts stretch. So if I was going to wrong this client, instead of welding this over here, I should have just changed the bolts and leave the rust in there, because at least the bolt will scream for 10 to 15 years. Even though I ripped off the client, because I didn't want to take all the rust out and it was just a pain. No. The correct way is you got to take everything out 100%. But, don't weld fire escapes. And now the EPA says you can't, because if I get caught welding on lead, it's a $35,000 fine anyway. So the fact that the EPA kicked in and is eliminating some of the weld repairs is good. But 98% of all fire escapes are bolted connection fire escapes. So now you're going to come in here and say, okay, what's some of the concerns that you have in regards to some of the welding? A weld 5 years from now is going to get needs either an X-ray, that some people call it an X-ray, or a radiograph, or it needs to be load tested. But as soon as I drill a hole through it and I put a bolt in it, and there's no rust evident in the connection, as soon as I put a bolt on any welded connection, that's called a certification. Now there is no need to load test it. There's no lateral load testing for the rails. As soon as I change a bolt on any one of these treads that used to have rust, if I just spot repair it, I need to load test that tread. But as soon as I take all the rust out of that tread, rebolt it, now I'm providing the city with other evidence of strength. There is no load test. So here's what is on the balancing. Every time you inspect a 50, 75, 100-year-old fire escape, you're basically saying, I leave behind one old bolt that the city wants some assurances. Not guarantees, they want assurances based on the code. And the code says low test it or certify it. Well, low testing is simple. I spot repaired, I low test. Here's the evidence, it passed, it didn't fall down. Or I certified it, which is even though the bolt was in good condition, I took that old square head or rivet bolt out, put in a brand new bolt, and now I've reset the clock on that for the next 25 to 50 years. I've sealed it with silicone, and so you got what we call certification, or in all the other codes it's called other evidence of strength. So the authority having jurisdiction shall accept a load test on this thing, but the confidence test makes me not have any rust in any connection. As soon as I've gone through that spot repair process, because the confidence test forces me, I have to load test it. But I want to avoid the load test because that $3,000, $5,000, $8,000, $12,000 buys no paint, buys no bolts. If you use that to change bolts, so 98% of all the fire escape is going to get changed out. That's called certification. Any welded connection, the weld stays. But to avoid future investigation, radiographing, x-rays, or load testing, as soon as I leave the weld and I put a bolt in it and I seal it all up, I've certified. So now the weld is there. The connections into the building, it's very simple, and we'll show you evidence, is that you've got walls that are either wood or masonry. If they're masonry, they're buried 8 to 12 inches deep into the building. So I have two options. On that connection, that between the veneer and the wall, we could have had water damage from the parapet wall for the past 50 years. The only way to do that is to drill a hole next to it and basically investigate and put that little snake down there with a camera and photograph it, because the city wants proof that the thing is embedded correctly. Another option is, if I'm going to drill 2 or 3 3/4 holes with a hammer drill into the masonry, can I just go 6 inches away and drill a new 3/4 hole, one hole, put a Hilti epoxy bolt in there under the right conditions, mechanically fasten it back to this connection, fix this connection at the veneer so it's all spalling and cracking, just repack it, make a new connection, put a bolt into it. Now what's the primary? It's the Hilti. What's the other one that's original? Secondary. It's called letting sleeping dogs lie. Why? Because when you touch it, when it's 75 to 100-year-old building and you start touching the wall, what happens? You try to fix one thing and other things are happening, so you basically let sleeping dogs lie, and instead of drilling 2, 3 holes to identify it from the front or exposure from the back, if I put in a new epoxy bolt on a masonry building, will you be satisfied that I've given you other evidence of strength? Have I avoided the load test requirement for you? Okay, so that answers that part. What about wood structures? All wood structures, you're not supposed to be lax screwing into a wood structure. What are you supposed to have? Through bolt. So if I go into that wood building, that residential property, and I put a 1-inch hole in the wall, and I stick my snake in there, and I photograph that plate in there, right? Is that evidence? Is that providing you other evidence of strength that I verify that it's not rotted out? Is it a big hole, or is it just a 1-inch hole with today's snake technology? It's a small hole, so I've identified it. But let's say I get outside and I have a problem. Can I just put another through bolt into that building? In that residential building? In that wood structure? If all of a sudden they've got all kinds of plumbing and things that basically are blocking my ability to duplicate, can I just put legs on that thing to the ground? As soon as I put legs on the nose of any fire escape to the ground, sitting on saw nose, didn't I just create a bridge? The house is a leg, the leg is a leg, between the two is. So have I eliminated the need for the through bolt? So that's all we're doing. So all fire escapes, the fix, they were built with bolts, they're going to be fixed with bolts. So you just change every single connection out and you put bolts in, because there's bolts already there. Every hole is already there.
How specific are the bolts?
That's a great question. All treads are held with 4 3/8. All clips over here at standard is pretty much 1/2 inch. All gussets are 1/2 inch or 5/8, depending on, and they just duplicate what's there. Now, everybody says, oh, you got to get me, you know, the grade 8 bolt or whatever. What fails a connection? The grade of the bolt or the expansion of the connection? So I can put in the strongest bolt you give me, but if I let that connection grow, basically it's not shearing the bolt, it's always expanding the bolt and ripping it this way. So to prove that, I can take a connection on a tread, take out the bolts, and wedge in a piece of wood in there, a good strong piece of wood, and have you step on it, she's not going to shear. So what's the real problem there? Is it the grade of the bolt that can't handle the connection failure, or the fact that the connection is failing? So all these connections during this refurb is going to get silicone sealed with 50-year silicone. So you open up the connection, you wire brush both sides, and you put in, you primer it, and before you put it together, you inject it with 50-year silicone, and then you run your finger all around it. That's the silicone. We've had some failures in certain silicones that right now we're also investigating. The rubber gasket. You know the last piece of rubber you put on a rubber roof, that one that has the glue on one side? We're now working with that to see if those, prior to putting a tread back together, can we put that on one side of the tread, and instead of having a silicone gasket, have a rubber gasket. And that way it can extend the warranty. But when you silicone a connection, you can at least give the client at least a 10-year warranty. We feel that when you do the rubber gaskets, you're going to be able to bring it up to 25 on certain components on the fire escape. The one thing you don't guarantee, paint. You don't guarantee cement. Why? Because they're constantly changing. But can you guarantee everything on the fire escape outside the fire escape? And you're managing just the connections? Yes. What's left for the client? Paint. Will this start spot pitting and spot rusting within 1 to 3 years? Yes. Should they have a maintenance program that includes spot painting over the next 3 to 5 years? Full painting in the next 5 to 7 or 10 years? Yes. In Chicago, you got to paint your fire escape fully every 3 years. Do they? No. But there's all these laws that were forcing the maintenance, but just nobody was enforcing. So what was your question?
What do you do with the base?
Where it's rotted into the...
Yeah. How do you verify that? Or do you not?
No, you have to.
How?
Well,
No,
normally...
you said that was buried, so...
Yeah, it was buried. Basically, it was sitting in asphalt that was up here.
Right.
So as soon as we get to a job and we see it not sitting on a slab and it's into the dirt, this is what we expect to see. So we basically either dig that out and basically create a slab. I've seen situations where we've actually got granite slabs and basically buried a granite slab in the ground and have the fire escape land on the granite slab. So knowing that it's in the dirt, I mean, we get to certain situations where they've landscaped so much, they've got 12 inches worth of landscaping and the legs are buried deep and they're all rotting out because they're constantly wet. Okay? Any other questions on this? This is basically to show you when you look in and you look down how much rust is growing on every connection. And I'll mention one last piece. See these through bolts? What's called the spacers? These spacers are basically on the gratings and all the treads of old 50 to 75-year-old fire escape. You can't get in there. You can't clean these out anymore. You can't pull this rod out and clean it. This is what new grating looks like. The new grating is basically, this is a welded rod on top that is not having a spacer. But every fire escape that you're going to get, there's going to be a disclaimer always for the treads and for the grating, and that the only thing you can do on those, because they're irreparable, is create a sandwich to hold them temporarily. Well, they should be replaced because as these separate and open, your foot gets stuck in. The only thing you can do is weld them back to the clip, but they're full of lead. So you only can replace them, or if you create a sandwich by putting a flat bar on top, a flat bar underneath, and then you run, bolts, carriage bolts. Again, you only talk about 3/16 of so it's not a trip hazard, you know what I'm saying? But it's the only thing you can do to basically get some more life out of grating and treads. It's a pain. The amount of money you're spending keeping some lead and no guaranteed treads and grating, a lot of now is flipping over to new grating, galvanized. Galvanized treads, galvanized grating, silicone shut all the connections. All the welded connections must be bolted to avoid blow testing. And so that's what you get here. You get one of these that, can we do it wrong? You sure. Just look underneath and see all the wrong ways to fix this fire escape. Can you do it right? Right is basically a rector set. Just take all the bolts out, put in new bolts.
Would the bolts typically be galvanized as well?
No, again, it's another, if the fire escape is galvanized, put galvanized bolts. But you just need to basically, it's connection maintenance, basically. Just keep maintaining your fire escape. The owners keep painting them, but the connections which have been primed, sealed with silicone, basically, the water can't get back in there. That's what's going to give it another 25 to 50 years.
I think we're concerned about the dielectric connections of dissimilar metals.
No, I think you're talking about if I have an aluminum fire escape?
Yeah, or any material where the metals are dissimilar enough for an accelerated deterioration can occur.
Yeah, all fire escapes are just plain steel. There are very few. As a matter of fact, we got only one case in here. I think I spoke with Sean about it. We got an aluminum fire escape, so we'll cover that aluminum fire escape question, and that is, every now and then you're going to get a fire escape that shows up that has aluminum, or it's a wood fire escape, and we run the question is, how do we load test a fire escape that's wood, that's already 25 years old, pressure treated, only lasts, on average 30 years, and can we or not load test that fire escape, or do we basically try to Band-Aid it enough so we get one last 5-year cycle out of it, but basically telling the client, listen, the city is basically giving you a 5-year reprieve to basically get it out of here and replace it. But the aluminum fire escape is a question in that there was a lot of fire escape built over the past 20 to 30 years by a guy out of the south who used to have an aluminum siding business, and he would also part-time and build you some aluminum fire escape, but they would come out and not have a permit on them. Some of the standards of the 100 pounds per square foot load test was not met, and a lot of them would lag screwed into the building. So, any other questions on this? Then we'll get back to.
So basically, there's two methods. When you need an engineer for the 3 phases to oversee it.
Yeah.
Either you do a complete renovation, which would be all bolting, you don't need a load test.
Correct.
If you do a spot repair, then you need a load test.
You need a load test.
So then you just go by pricing.
And then it's just the client picks the pricing that best fits in. You can also just replace it at this time. Say, hey, why don't you put a brand new galvanized fire escape for the same thing? Because every now and then the number is not that far off. Sometimes the repair cost is 75% of the replacement cost. And some people use that as a mind. If I'm already at 75, what's the advantage that I get if I go the full refurb? Well, let's talk about certification versus load testing. As soon as I load test it this year, 5 years from now I'm going to load test it again. So there's another 5, 10 grand coming for this load test. The fire escape could pass now 5 years from now because we did a great job of spot repairing it. But 5 years from now, $3,000, $5,000, $8,000 for load testing. They certified it today. They just went, you know what, let's spend the extra 5 grand, let's just totally recertify the whole thing and give it a paint job and silicone shut all the connection. 5 years from now, no load testing. Because I'm going to be providing other evidence of strength. 10 years from now, what are you providing? Other evidence of strength. 15 years from now, so on average, if you keep maintaining it and you have a good policy with your fire escapes now under the paint roll, you can have 15 to 25 years that you're going to be basically using the other evidence of strength. Hit the 25-year mark, now what are you going to get? You may want to, because now you're in that 25 to 50-year life cycle again, do you want to change all the bolts out again? It's really a call with the city officials.
You had mentioned before that the requirements for construction of a stair exterior egress system is not dissimilar to what Chapter 10 requires for egress stairs. I can't tell you how many fire escapes or egress systems I've seen that are super skinny, don't meet 36 inches wide, don't have a 9-inch tread and all the rest of it. So how can we take an existing non-conforming stairway and say, okay, it's kosher, and still meet?
Good question. Let's just clarify that, and then we'll start the show again. But you're basically saying, is this a fire escape or is this a means of egress? If it's a fire escape, the minimum requirement, guys, is 22. Rise and run is 8 1/8. Right? And that's a fire escape. So what that means is usually a third means of egress. It's not your second means of egress. It's almost like, hey, I have an attic, and I'm putting in a third means of egress. So I'm using a fire escape. I'm going to classify it as a fire escape. So fire escapes are 22. Second means of egress. No, this is an apartment. I want that window to become a door. I want 7-Eleven, 36 inches wide. I may want a cover. I may want a kick plate, even though it's a... So you're looking at an exterior stair. You're not calling it. So thousands of fire escape, thousands of exterior stairs got built under the fire escape code to satisfy the egress code. Now you have a pre-existing condition. When I go to examine a fire escape, I'm just certifying this system, not whether or not it's conforming, was built correctly, and a lot of that is just research back into the jacket of the building. Did somebody even put it up legally or not? So you have the right, if there was never a permit pulled on it, to basically ask for one of two things. Have the fire escape reverse engineered so that there is a set of plans that you can put in the jacket, or accept it, have the building commissioner accept it as a pre-existing condition, non-conforming, like every other building in garage in the backyard up against the neighbor's yard, 6 inches over the property line, whatever, so it's really, the new ones getting built should be built, you have to say, is this a fire escape or a second means of egress? If it's a second means of egress, you're looking at the exterior stair code. So that'll help you. So fire escapes, but the norm is that everybody's walking in and slapping up a fire escape 22 inches. The norm here is 24, but the minimum is 22. So that's where that abuse was happening for many years. Okay? Question, we'll continue with the building code. Exterior stairs, when you're building exterior stairs. Well, while we're at it, let's talk about, exterior stairs. How many decks in the back of a building are built as your second means of egress? So they have this nice deck off the back window. It's clearly your second means out, and then you're going down these set of stairs. And what's the thickness of the wood? 5/4. What's it supposed to be? 1.5. So whenever anything, can you build a fire escape of anything other than wood? I mean, other than metal. You may make it out of wood, but you must meet the fire rating. And in order to meet the fire rating, will 5/4 do it, or does it need 1.5 inches? 1.5 inches. And a lot of decks are built to what, 60 pounds a foot or 50? So if you're going to use your deck as a fire escape egress, what do you got to do? What's it got to be built to? 100 pounds per square foot. How many pre-existing ones are out there that basically now it's a catch-22? So some cities basically make you double up the deck. The 5/4 just double up. There's your 1.5 inches. Stiffen up and put some more beef on the stair. I mean, there's many things they have to do, but the rule of thumb is, what do you build on the building? If it's wood, can I put a wood fire escape on it? If I have a wood building, can I put a wood fire escape on it? Yeah. If it's a brick building or a metal building, can I put a wood fire escape on it? So, must meet the building type. So when you're constructing a fire escape, you can match the building type. Traditionally, all fire escapes are built out of metal because they last the longest. You can ignore them the longest. Pressure-treated fire escapes, what happens to them after 15 to 25 years? The water got into all the joints, did what to the bolts, into the nails, into the screws? Ate them, and then they want us to do what? Load test or certify. So wood structures on a case-by-case basis is a problem, because a lot of times all we do when it comes to a wood and working with the city official, we say the best thing to do here is get the metal plates and basically reinforce all the joints, seal up all the joints, and usually you give the client either a 5 or 10 year rule that says, hey, very soon your fire escape is so old, you got no time left, and we can't load test it. So it's really a play with the building official to say, just how can we load test this? I wouldn't guarantee the load test on a wood structure. You know what I'm saying? So, but you can reinforce it to the best of your ability using metal, because a lot of times 2 to 3 inches from the end of every piece of wood, it's already rotted because the water got in that way and ate. So the rest of the wood is nice and pressure treated still, because a lot of people don't realize that pressure treating is not the entire piece of wood through the interior. It's just outside. And as soon as you cut it on either end, that's where it basically, and nobody treats it. You're supposed to use that green chemical where you're supposed to use a suit. Nobody ever does that, but they leave all these joints open on these beautiful fire escapes, wood fire escapes, and they stop rotting immediately for the first 2 to 3 inches. And no matter how many nails you put back in that joint, it can't. So you have to use metal to basically span 6 to 8 inches away from everything and then start screwing. So that's what, whenever we hit a wood deck, we basically say metal's coming. To basically buy 5, at the most, 10 years. What about all these wooden porches in the back of the building? Horror stories. Case, yeah, collapse kills 27 people. Fire towers. Some of you may recognize this. We have somebody here from Waltham or Watertown?
Yeah.
Is this Waltham or Watertown? This is Waltham. I inspected this thing 4 or 5 years ago. They were using it for training. And that day, I basically, when my hammer testing, this is interior. We recently got a call back from the fire chief looking at it to say, hey, we want to look at this again. And somebody had fixed it, and they started reusing it. We did Brookline fire tower. Guess what happened to theirs? Same issues. The great thing that I got on the fire tower in Brookline, though, is they had a dummy that they used for training. And I haven't incorporated this in yet, but I basically took their 150-pound dummy and I started throwing them down the fire escapes. So in some of our future classes, I actually we were holding up a dummy and we say, hey, tread falls. We just throw a guy down the stairs and we show them just what happens. We also show, in case of rail failure, what a 10-foot drop would do. So we basically drop the dummy, so either on the interior or the exterior, we're just basically going to show in the future, just the, you know, what a fire escape does to you with metal. Metal is very unforgiving, you know. It'll break bones and basically, but this is the kind of rust that we found. This is up in Chelsea, old folks home, up on the hill. Took them 2 years before the state finally gave the money that it took to basically fix the fire escapes. 2 years later. So if the war didn't get you, fire escape will. And this is what also happens to fire escapes. They get damaged. Here's a great question. If you get a fire escape that gets knocked up by a trash truck or a moving truck, and they just damage the lower stair, what part of that do I fix? Just the stair? Well, the whole fire escape now must be brought back into certification. So every now and then we tell a client that just calls us up screaming that a trash truck or moving truck smashed their fire escape, their 8-story fire escape or their 5-story. So we call that a fire escape lottery ticket. We say, listen, just so you know, all the abuse you didn't get fixed, all the things you didn't do, now this truck now has to fix all that abuse.
Their insurance.
Their insurance. And if it's a hit and run, the homeowner's insurance or the building's insurance will fix the whole thing, because I can't just fix the lower part. I have to fix the whole thing. An engineer must certify the whole thing and bring it back into operation.
Just put a tweak the whole thing.
The whole thing must be repaired and painted. So a lot of times, instead of $5,000 repair, it's a $25,000 rehab on the job, simply because the code requires that the whole entire system be brought up into code. This is funny. I think this is Haverhill, City Hall. Anybody see the missing treads? Yeah. This is typical housing. You know, when we go and paint the hammers in Boston, you know, we were painting the treads, and they all started falling. Some of these things we find as we get there. This is already there when we get there. How nobody saw this during their alley walks or whatever. Did you see the missing treads?
That's on the City Hall.
City Hall in here. This is the piece. Welding. Can't do it anymore. Can't weld on anything that has lead.
Well, they remediate it first, can they weld?
It's not worth it. By the time you basically take all the lead off of a fire escape, and here's the catch-22. This happened to me in Harvard. We had a 10-story structure that needed repair. Prior to doing the emergency repair, we needed to remediate the area so that we could do some repair to it, because it had lead. The lead guys couldn't get on it because the fire escape was dangerous, to let us fix it so people could get on it. We gave a catch-22. So what they did, they had to build a scaffolding tower and basically shut down and build a brand new fire escape system. And it turned into a $500,000 situation, because it was on the back of a commercial residential. So you can see from below, the welds, the typical is leave the existing hardware on it, just weld in those, or weld some rods. And again, they never pull a fire permit. When's the last time anybody see a fire permit being pulled to do a fire escape repair? You would get called there usually when they set the building on fire, or they set the grass down below on fire, or do something. And usually by the time you get there, the guys, they've hidden the welding machine, and they've got their paint buckets out to say, "Oh, what are you doing?" "We were painting, and somehow the grass caught on fire." Well, my guy must have
You won't bless that without a load test now.
I know, but there's no welding anymore anyway. And if there's a properly welded connection, to avoid the load test, as soon as you blow a bolt through it, on a properly welded connection that has no rust inside, as soon as you put a bolt into it, there's no need to talk about the weld. They don't care. The bolt is the primary now. So this is us when we put the piece together. We cut it and created a model piece to bring here for you. And this is the old one. This is the new one going off to the side. So used every day. Kids come out here for recess every day. Kindergarten to 8th grade. So as you can see, fire escapes are out there, ready to grab people. What we're trying to make you do is not have you walk up and down these things. From the ground, you can see now evidence of rust. You can see evidence of non-maintenance. And the main thing that we want to remind you, whether you're a building inspector or a firefighter, is that you don't I'll show you that in a second. We can just go back one. This over here, the one thing we don't have firemen doing when they walk up and down in the middle of the night on a fire escape, we don't have them walking around with a little ping hammer to help to identify whether a fire escape going up is good or not. This is a reminder. That's how quickly you can lose the firemen. Okay. Now, I've got a chance to look at all kinds of fire escapes nationwide, so we inspect all over the nation. This is in Rutgers University. I think this is a frat house. And believe it or not, that's a fire escape. Just service these two windows.
That's another interesting, because they were vendor driven, there's many different styles, designs, attachments. It's amazing.
This is just an odd duck that I've never seen this in my life. It's about to have one, not to have two. Imagine some drunk fraternity guy basically trying to get away from whatever, and he doesn't even know how to hang onto the pole. So firemen, you know, the kind of training they need just to hang onto the pole and slide correctly. But imagine, and this is at Rutgers University. This is a Rutgers building.
Have you seen emergency slides, egress slides?
I'll show you one right now. Guys, you remember the point here that we're trying to say is that on a lot of these buildings, the key, that's an 8-year-old child right there. This is the Bridgeport fire, but look how many fire escapes. Look how that fire is raging. And when they got there, this was a rescue mission, not a firefight. So they had to let that go until they got everybody down. Those 5, 10, 15 minutes of time it took to get all the people off the building, then they could start fighting the fire. That's a lot of waste. How many people here have trained their 8-year-old daughter to, you know, go down a ladder and jump? So it's not even go down the ladder and hit the ground. Go down the ladder, which is not working, and jump 10 to 12 feet. And imagine the ladder let go while she's on it.
But right now, firefighters are taking out the ladders and rolling up the hoses. But earlier in the night, when they pulled up, there were flames coming out of the side of the building. Firefighters say it was one of the scarier moments because when you pull up to a building and you see children and mothers hanging off the side of the fire escape, smoke swirling around them, isn't that scary, scary stuff? They got up there, got the ladders up, and they said nobody got hurt.
The fire escape, there was 3 or 4 people hanging off the fire escape. They couldn't get off. They were just on the fire escapes. I had people hanging in the fire escapes at the rear of the building, and on this side of the building, we had a bunch of people on that fire escape.
Well, about 50 people were displaced inside this building. Our firefighters say there's good news tonight. It looks like everybody will be allowed to go back in, except the one unit where the fire was in. They said, that's good luck to them tonight. I'm Bob Wilson, on the scene of Bridgeport, News 8.
That's how quick, you know, these things can go from, you know, and this happened in Marlborough Street, 4th floor. She got out of the fire. She saved herself. She got on the fire escape. The fireman got up there, and basically, here comes the ladder. You're safe now. Don't worry about it. You know what I'm saying? And he's reaching for the ladder, and the last split second, it all goes away. And what happened to her? She fell. He saved himself, and the woman died, but the daughter, the niece survived. This is some buildings when we do the exposure. It looks beautiful out here, doesn't it? But between the veneer and the actual masonry block wall, what's happening in there? Water. 50 years of ping roof water coming in between that little 3/4 gap, that 1/2-inch gap between the veneer and the masonry block wall. It rotted all the steel. What happens when you load test things like this? They fail. So this is one of those situations where instead of spending $500 to open up a wall and tell me what's wrong with it, if I put a new epoxy bolt 6 inches away from a main connector, do I care what this looks like inside? If I got a new connection? Let sleeping dogs lie. Look at all the problems they have. As soon as they started exposing this, the other things came up that were inside the building. It's a can of worms. And all I have to do is 6 inches away, put a new epoxy bolt there, anchor it. If you have a question that, you know, a row of 10 connectors individualized, you can basically seat a 2x2 or 3x3 angle underneath it, run it to full length. Every 2 feet you have an epoxy anchor, and then you basically connect all the support back to this one piece of angle. You've just unified. You've unified all the connections now. So in order for that thing to fall, you have to rip the whole wall down. unify all your connections that way too. Singular, you either do a singular repair or unification of the connections. Nothing left. And this was actually on the 20-story building in Chicago that the structural engineer passed originally. Another structural engineer said, no, we need to do some spot inspection of the wall because they were going to turn this into housing, senior housing. And during this investigation, that's when they found it. This is another one we did down in New Jersey. Water had been getting into from the roof coming down. Look at all that, all rotted away. So we can go and dig these out, and it's a big can of worms, or just create a new epoxy connection next to it. Or through a piece of angle and marry all of them with a bolt. And so every 2 feet you have an epoxy. Or a through bolt. So don't think epoxies are always in, because everybody's like questioning epoxies now. You can actually run another clip and put a through bolt somewhere inside the building. When, you know, as long as I don't have something that's ornate that stops me from getting. But if it's just a sheetrock wall, open up a hole 12 inches wide, get in there, put in a plate, put a through bolt, and avoid the epoxies if you have questions about the epoxies. This is the other thing you can do, drill holes. So take that 3/4 hammer drill and do that, and then send your snake down there. But when you send your snake down there, what do you get to see? You get to see a lot, or is it kind of questionable what you're going to be able to see? So if it takes 2 3/4 or 3 3/4 holes for me to get some visual advantage to throw my little snake down there, why don't I just take that thing and put a hole over there about 6 inches away, put an epoxy bolt there, and then mechanically put a clip back to the main support. So keep my original, give you a new one, and now I'm at 150, 200% of what's required by law, because my primary now is brand new. And let sleeping dogs lie. If they look good, just leave them alone. This looks pretty good. But because I had to verify prior to the load test, right? So we highly recommend that you duplicate connections into the building. This is what the interior looks like if you're looking from the inside out. So these are the kind of things you're going to be seeing with that little snake. Either damage or it's going to be in pristine condition. You can see it's not always the greatest advantage or vantage point from where you're at, but okay, this is all the verification process. This is load testing. Load testing can be done with sandbags. Load testing can be done with water bags. Load testing can be done with a cabling system where you basically raise a weight from the ground. And on this one in California, we chose to use a 10,000-pound truck underneath, ran the cabling up through the floors, and because the floors that had a piece of angle going across, the engineer determined that by pulling on that middle of that angle, you basically were creating a load of 3,000 pounds. So we load tested 10 stories that way. So the engineer has to provide to the city official a criteria of what the load test is going to be. Is it going to be sand? Is it going to be water? Or is it going to be cabling? Okay, that's what the engineer oversight is all about. And then you basically start raising the back of a truck. Or you can have a big, pile of bricks on the bottom.
Is that guy standing underneath the fire escapes?
No, this is those are all the fire escapes above. So
I know, but the guy that's on the chain falls.
right, but the fire escape he's doing is not the 10th floor. So you got 7 fire escapes between them. But otherwise, when they get closer, you have to pull it away and you have to put a scaffolding underneath. That's what we did. And this is us reading the piece right there. Once we hit a certain height. Here's another fire escape that we inspect that's missing pieces. So some of these old ones don't even have a protective rail. Some of these don't even have enough for your foot. In some old fire escapes, they only have a 12-inch platform for the firemen. These are the 75-year-old or greater fire escapes, and that even the platform can't put a rail because now you can't even get yourself. If there was a rail there, you couldn't even get it, but it's a fall hazard. This is the fire escape that we were involved in the case of fireman fell. From that floor, fell through, landed down here, went back up and saved a woman and a child. But when he was done with the rescue, he basically shattered his vertebrae. The uniqueness of this case is that this wasn't just a claim for workers' comp and disability. He sued the owner directly for negligence. When we went back to investigate this 2 years later, the only thing that was fixed on the fire escape was the 3 treads he fell through. The rest of the fire escape was still falling apart. So it was during this investigation that we got to work up with a metallurgist who basically gave us a lot of the insights that we share with you today. Grow 1/4 inch of rust, you need to let it go for 25 years. To get a 1/2 inch of rust on any connection, you need 50 years of unchecked growth. So from that, we basically came in, and we now can explain to you, this is us going up the fire escape. And as we're going up, treads are falling. This is a fire escape that had firemen on it now, lawyers, owners, defendants, and we're all out walking up and down this fire escape and all the pieces, and this thing's just falling apart as we walk. So they settled this case quickly after this because we proved that 2 years ago or 3 years ago when the fireman got hurt, the guy did nothing but fix the 3 treads. Yet there was 50 years of neglect on the fire escape still, so he had it repaired by a vendor. And what did that vendor fix? Those 3 treads. What about the other treads that were ready to go? Well, he wasn't asked to fix those. So let's talk about, and we'll go slowly now with just how fire escapes and how rust grows, so you can understand what you have out there. All fire escapes in the United States, when they were built in the 1900s and sooner, so some fire escapes in Washington were built, in New York and Boston were built in the 1850s. So the older the building, you're going to start seeing fire escapes was a means of egress at those times, but usually on people that had a few bucks, because otherwise everything was a single staircase up the side of row houses. It was only after several fires killed many, many people that people said, you know what, we need an answer, so they started putting connecting balconies on the back of these row houses that basically connected you to your neighbor and you crossed the firewall. So that's the reason for fire escapes. Around the 1930s and 1940s, the building code changed and said, you know what, we're not going to allow fire escapes anymore. We want all fire escapes, all staircases to be 2 in on the interior, and on the exterior, basically we just want to maintain these fire escapes until they've disappeared. So everybody expected by this time that fire escapes were all going to be gone. Nobody expected anybody to find duct tape, paper clips, and bubble gum is what everybody's been using to hold these things together. So they expected all these buildings to be down on the ground by now, and these fire escapes were going to go away. So maintenance was the only thing. They just kept just keep it painted. But now a lot of these fire escapes are 50, 75, 100 years old and still here, and they look like that. So now what we're faced with is something that should have been replaced or removed or should not be there anymore because a new building went up in its place, and firemen still have to use it, tenants still have to use it, and nobody had a plan, nobody expected them to be here. So when you have a piece of fire escape, you buy a 20-foot piece of steel. You cut it into little pieces and you make treads, you make rails, you make supports. When I take 2 pieces of steel and I put them together, do I prime and paint it before I put them together? No. When I bolt it or weld it or rivet it, right? And I join the 2 together, do I prime or paint it prior to the assembly? So I take this tread that I've assembled out of these 20-foot pieces, and has anybody who's ever sweated a piece of pipe to basically solder it? What happens when you put fire on a piece of metal? What's it start doing?
Expands.
Well, it expands, but it also starts sweating. It looks like it's drying. Like it looks like the metal was wet. And when you heat a copper, you start seeing it drying for some reason. That whole wet, dry look. That basically metal already has moisture in it. So I got 2 pieces of metal that I put together. I bolted it, riveted it, or welded it, and then I paint this little tread. Where's the first failure going to happen on this tread or on this rail or on this support? In the connection where is there any primer in there between the 2? Now the only thing keeping it from rusting is what's called air, because I need air and water. I already got the moisture in the metal itself. What's it need in order to grow? Air. But some guys sealed it with paint. So as long as you keep it sealed, what doesn't get in there? The air that needs for it to rust, right? But like all metal that is bolted, in the summer it heats and does what? In the winter it cools and does what? And as soon as you do that with stiff paint, what's it do to the seam of paint? Cracks. So that's where water gets in. So in the first 5 years or so of a piece of metal's life, you get surface rust. What you're supposed to do diligently is every 1 to 3 years get in there, wire brush it, and apply a new sealant to basically stop air from getting back in there. Do people do that? What happens in the next 10 to 25 years, because you never cleaned it, never painted it, water got in and did what to the joint, which is over there. Got It penetrated from the top of the clip to the bottom of the clip. And did what? Rust. I got a 16th, I got an 8th, I got something. I got a rivet. Does it eat the rivet yet? Or is it just surround the rivet and start eating it? Surround it. But then now the rivet, the bolt, whatever, as this grows from a 16th to an 8th to a quarter, what happens to that rivet or that bolt? Does somebody go in there and loosen the nut a little bit to give it some breathing room? So as it starts stressing it and pushing it apart, it basically takes, like spaghetti, it takes something, just start pulling it apart, so you basically compromise. And as that grows, and I'm using a tread as an example, as you start pushing it, especially on older fire escape with rivets, they only have very little shaft. As soon as you push that away, that's why on a fire escape, as you're going up and you step on it, even though it's got rust in there, you're hitting the shaft. But as soon as you keep pushing that angle outbound, what happens? Eventually you run out of shaft, and what happens? You have nothing but rust and your foot pressure to do what? Break and pass through, and that's when firemen are going up in the middle of the night. So basically, once you've got about a 1/4 inch, depending whether you have a rivet or a bolt, the nut is either eaten, the shaft is either eaten, or you've basically pushed it away from the rivet so that now there's nothing holding it. There's no stoppage, and that's what happens. So as we were walking up the fire escape, we had all this kind of rust in the whole, a fireman 2 years ago, basically fell through this thing, and as we were going up, just from our natural walking, what was happening. So they settled the case pretty quickly on that. Now I'm going to talk about how fire escapes are built and put together. So we talked about masonry buildings, we talked about wood structures. That's it. There's nothing else that is out there that we're attaching to. So, believe it or not, a piece of steel is only 8 to 12 inches buried into the wall. So you got your veneer, which is not structural, and then you've got the wall that somebody created, a pocket, put in a T-bar or an angle or a C-channel in there and just pack it. Just put cement around it. Do you think they'd even put a stopper in the back or some sort of bar in the back? Nope, there's nothing. As soon as it's spalled, it'll pull right up. So that's the standard connection that you see, whether it be a railing sticking in or whether it be it's basically through the veneer. As water gets in here on your sills, what does it do to that support? Rust jacking, ice jacking. As rust grows 5 times, a 1/4 inch will grow to 1 inch as it expands. What's it do to the bricks above it, the bricks beside it, the bricks below it? What's it do to the sills? It does exactly this. As it pushes up, it snaps all your sills, creating more pockets for water to get in there. Do what? Start ice jacking and rust jacking in here, open these up, and the water keeps feeding its entire life. And as that grows, you basically are spalling the whole wall. Here we have 2 staircases on 1 C-channel into the wall, and no brace. See, no brace here. Only 2 staircases, and that's only 8 to 12 inches deep. So as soon as you load that with tenants and firemen, what's going to happen to that piece? So a lot of them have the bracket, and sometimes the bracket is embedded into the building, so the water channels into here and does what? Okay? So you have to have answers for these. Do you want to continue going back into the building, or do you want to basically put an angle on the side and basically have an expansion bolt and basically cut this away from the wall and then repack the wall so that there's no more water going back into the building? And what's holding the bottom is just an expansion bolt to help basically save the envelope of the building. So these are suggestions to change some old practices. This is a through bolt on the inside. Sometimes there's so much pressure that it basically starts pulling the bricks on the inside. A lot of this is some of your factories. You're going to see a lot of these through bolts that look like this. And a lot of them is not a plate, it's a donut. And as the brick deteriorates, they start pulling. And outside, you start seeing a lean on the platform. Recently, and again, Massachusetts, because of the medical marijuana, in case you want to start growing medical marijuana, and then you want a nice wet place, fire escapes are great for you to start growing ferns and bushes and stuff, but this is an indication when you got this much green on a wall, there's a lot of water coming down. Broken drain pipes, platform that's pitched backwards. Some of your theaters, this is a theater, a lot of them have diamond plate or cement pads that basically fill with water, and they rot out the whole structure, and Look at this. This is an interior of a parking garage. You know how many parking garages you guys have that have an exposed stairway that's closed, but the windows are open and the rain and the snow gets in there? And all of them are steel pan stairs? All exterior steel wooden stairs. This is a Boston library. 1 inch of rust on a Boston library. That gusset is doing nothing. Again, if you want to grow plants. Nobody's ever going to go check your fire escape to see if you're illegally growing any plants, are they? Just in case you. And then you got legs in the ground. This is always hands on a sonotube. Leg is a leg. Building is a leg. You got a bridge in between. So that's sometimes a solution whenever you can't fix the connection into the building. Basically, you put a leg to the ground and you reattach. So this is attached into the building, not necessarily all the way through because it's in the connection here, but it has a leg. Got it? The barbed wire is extra. Sometimes you get smashed, you know, fire escape gets smashed by a truck. This is all veneer damage. And a lot of times they don't go beyond this, they'll just stay right here and they'll patch this in.